everyone, welcome back to mahasarkar.co.in. In today's video, we are going to learn about refrigerator. If you remember, in a previous video, we have dealt about the heat engine. What was the heat engine? Then if you remember, it has three different portions. First is the source of heat, we call it hot reservoir. Second is the movable piston with cylinder, and the third is cold reservoir. Heat is given through the hot reservoir, which is used by that cylinder. The expansion of gas in the cylinder takes place. That expansion leads the piston to move, which performs the mechanical work, and the remaining heat is extracted by the cold reservoir and exhausted in the atmosphere. Now, what is refrigerator? Then I will see. The refrigerator is the device which converts mechanical work. Now this mechanical work is given by the means of what? Electric energy into heat. Now heat is reduction, so heat reducing agent it will act as, or in short I will call refrigerator is an artificial coolant. Okay, how it works? Then I will say again, it works on the principle of second law of thermodynamics. Mechanical work can be completely converted into heat, but heat cannot be completely converted into mechanical work. Like heat engine, it will also have three different portions. Like heat engine, it will also have three different portions. So let's start the parts of refrigerator. Now, refrigerator also has three parts. The first part we will call cold reservoir. Second part is consisting of three different portions in which compression, expansion with valve is there. And the third part is the hot reservoir. Okay. Now, this second part has some coils in which expansion is there, then compression is also there, and some refrigerant is there. Materials like fluorinated hydrocarbon, such type of materials are there here. They are combinedly working here in this second part. Now heat from cold reservoir is extracted. Say QC is the heat given to this second portion. Second portion is supplied to the electric energy. Second portion is connected to what? Electric energy. So this heat sent by that cold reservoir, that say QC, is then transmitted to the coil, and this heat is the material of that heat sent through that cold reservoir is get expanded say by this electric energy at low pressure. It is expanded at what? Low pressure. So that when it is expanded at low pressure, its temperature is initially increases. Okay. Now this process in which no exchange of heat takes place till the complete expansion takes place. So I would say this process is adiabatic process. So this process takes place adiabatically. This all the things takes place what? Adiabatically. Now this expanded heat through the valve which is connected here, valve connected here, is sent to the next compressor chamber. That compressor compresses that gas. Because of that, its heat is now sent to the cold reservoir. Now what is cold reservoir contains? Then cold reservoir has Suppose this is the pipe connected to the hot reservoir, then that pipe contains the hot air. In this, it liquefies around that pipe, and then that heat is extracted to the surrounding. Okay, so in short, how it works, if I say, then cold reservoir sends heat from the refrigerant using the valve. That heat is sent to the middle part, that middle part consisting of the adjustments of expansion, compression and fluorinated hydrocarbon as refrigerant. This gas is getting expanded, then that expanded gas is sent to the compressor. Compressor compresses that gas and liquefied is, because of that liquefaction, the heat is extracted into the surrounding. So here, if W is the work done by that electric energy, then QC, if QH is the heat at the hot reservoir, then heat which is extracted at hot reservoir is W equal to QC plus QH. So whatever was heat present here, so this will be the actual component of refrigerator. This heat which was present here, that is also get extracted. So heat extracted in the surrounding is the heat of hot reservoir plus heat of what? Cold reservoir. Okay. One term is that we will call performance of refrigerator, or we will call it is quality factor or coefficient of performance. Then coefficient of performance is the ratio of heat extracted, that is from cold reservoir, divided by work done. But we can say here which heat will be more, then I will say QC if it transmitted, so that total heat which is extracted from cold reservoir will be more. So here by first law of thermodynamics I can say W equal to QC minus QH. So if I replace here, then I can say K equal to what? QC upon QC minus QH. This term is also called as coefficient of performance. This term is also called as what? Coefficient of performance, or it is also called as what? Quality factor. It is also called as coefficient of performance or quality factor. So we have to go through the structure of heat engine to understand the refrigerator in an opposite manner. So remember, refrigerator is nothing but the heat engine, but which works exactly opposite of that heat engine. So these are the simple steps to explain the concept of refrigerator. I hope you understood this video. Thanks for watching mahafarkar.co.in. Have a nice day.